Hello, I am Alice Baker, and today I will be talking about how scientists use their observations of marine flora from two separate locations to understand their environments and how they are changing. In this presentation, I will be referring to bibliographies A, B, and C. So marine flora are plants that live in our oceans. They provide shelter to the marine life as well as food for both land and sea animals, since they have many nutritional benefits. However, one of the most important aspects of marine flora is their ability to provide our Earth with oxygen. These plants provide around 70 to 80% of the oxygen going into our atmosphere, which means they are crucial for sustaining life on Earth. What I'll focus on today is the extreme sensitivity these plants have to changes in their environment. Changes in water chemistry and temperature can have a significant impact on the marine plant species and their ability to survive. So the first climate record I'll be discussing is Neptune grass, which is found in the Mediterranean Sea. But to understand their behaviors, it is important to understand what the current climate is like in this area. The main issue with this changing climate is the weather. Currently, the Mediterranean region is changing significantly due to an increase of local populations and urbanization, leading to overexploitation of the local resources that are needed to sustain the increase in human presence. Here, the summers are only increasing in temperature, and some areas are experiencing a significant reduction in precipitation during the winter months. Researchers have been tracking this area and its climate, and over the last 140 years, the mean annual temperature of the region has increased and is now around 1.5 degrees Celsius above what it was in the 19th century, leading to negative impacts not only in the ocean, but in the surrounding towns as well, whose agricultural practices are suffering. In Figure 3, you can see that while warming with a different intensity, both the lower and upper regions are experiencing significant sea surface warming. In addition to the warming, the sea is also experiencing a level rise of almost 150 millimeters since the 19th century, and the surface is experiencing an increase in salinity levels down to a depth of 1,500 meters. The high sea surface temperature being recorded in the Mediterranean has shown to be directly related to the decline and in some cases, even complete absence of Neptune grass meadows. Figure 5 depicts the current meadows in green and the coastlines with Neptune grass regression in red. As you can see, there's much overlap between the two images. More increase in temperature is expected to continue and put even more stress on this species and its ability to survive in this environment. This species has been experiencing a decline in growth and sexual reproduction as a response to the rising temperatures in its environment, causing many locations in the Mediterranean to experience the decline. One place in particular is Stagione di Marsala, a semi-enclosed lagoon along the western coast of Sicily, which within the last decade has been seeing regression along the inner part of the lagoon. The rise in sea level noted in this climate is also contributing to the distribution struggle the species is going through. Neptune grass can be found in shallow waters all the way down to about 40 meters deep, and they have become accustomed to life at these depths. Increasing this, especially in the shallow regions, causes the species to struggle in readjusting to their new environment, and the population does not always survive. The next climate record I will be discussing is eelgrass, which is found in the Atlantic Ocean, specifically on the east coast of the United States. Like the Mediterranean, the Atlantic Ocean is also experiencing significant warming. Temperatures have been at a record high since 2023, causing this ecosystem to undergo a marine heat wave. This heat stress is having severe impacts on the local flora and fauna. In Figure 4, you can see the sea surface temperatures across the North Atlantic in June of last year and how it compares to the 1971 to 2000 average on the top, showing that in some places, this temperature are up to 5 degrees Celsius above their normal levels. The bottom map shows the actual temperature of the surface in June of last year. The white and orange areas show where the sea surface temperatures are above 26 degrees Celsius, while blue areas show where it is below. And the dark orange means that the area is closer to temperatures around 32 degrees. In addition to rising temperatures, scientists are also noting sea level rises in this area. Coastal cities along the East Coast are experiencing an increase in frequency and severity of coastal flooding. Since many of these areas are only around 1 meter above sea level, they are especially vulnerable to the increasing changes in the ocean. Eelgrass is the dominant seagrass species on the East Coast, but is currently experiencing significant loss to its populations. Due to factors such as warming, light reduction, physical disturbance, and eutrophication, which is when a body of water becomes over-enriched with nutrients, the species is struggling to acclimate. Much like Neptune grass of the Mediterranean, eelgrass is experiencing mortality due to the temperature rises in their environment, typically in climates above 25 degrees Celsius. An example of this was seen in Chesapeake Bay, following a heat wave where water temperatures exceeded 30 degrees Celsius. It is also suggested that mortality rates can increase when eelgrass experiences short-term exposure to water temperatures about 4 to 5 degrees Celsius above their average in a normal summer month. Recently, scientists have started monitoring eelgrass behaviors and how their current climates changed their population. They have noted that above average temperatures in the summer directly correspond to a decrease in probability of eelgrass presence the following year. Reversely, temperatures below average in the year before, about 0.5 degrees Celsius, are associated with a high probability of eelgrass presence. Figure 6 shows some of this monitoring by the researchers and how much eelgrass is able to survive and spread. In conclusion, eelgrass and Neptune grass are excellent indicators of their current environment. As soon as there is a change in their water level, temperature, or chemistry, observable symptoms start showing up quickly, such as rapid mortality and struggling populations. Therefore, scientists can use marine flora as a climate record.